All right. So here is continue our discussion. And now, in previous section, we have come across, yes, there is reversible reaction for equilibrium. They can start from both sides, but can we predict the final result? Well, the answer is yes, with the term called equilibrium constant, which is a ratio between product and reactant. Okay, now, but you should be careful. All of them are concentration or molarity ratio, not mole ratio. Okay, let me rephrase again. Not mole ratio. With the coefficients, we can define our equilibrium constant like this. The word Kc, C stands for concentration, is the concentration ratio between product and reactant at the moment when equilibrium is achieved. So, if the equilibrium is not achieved, that means the concentration for each species can keep going change. So, we cannot measure the Kc. Now, for Kc, there is only one point you need to memorize is the value of Kc is affected by the temperature only. Well, that means if the temperature is not changed, other parameter, for example, pressure, concentration, or catalyst will not change the value of Kc. So you should be careful. And some of you maybe notice that with the different equation and with different coefficients, actually the value the unit of Kc can change too, right? So in the following checkpoint, we will go through it. Now here shows. So let's finish this checkpoint. Well, you are given this chemical equation. So what is the forward and backward reaction? Now please write it down for me. Okay, you are given 20 seconds. I think it's enough. Like this, okay? Now, so maybe some of you may wonder, first, why I insist use the double arrow, because I want to emphasize this is a reversible reaction, all right? The second one, some of you may notice that why I should include the physical state. Well, be honest, the physical state is not necessary here. Well, unlike in book 3C, enthalpy change, the physical state is must. Here, the physical state is optional, but I will recommend you to write down because this is a good habit for the following calculation. So I will explain this later. Okay, so far this is a good habit. Okay. Well, next one is write down the expression of equilibrium constant and state the unit. Now, there are two answers you should mention. The first one is the expression. The second one is the unit, right? So let's do it. Right here. Well, according to our equations, be something like this, okay? Now, but what about the unit? Now here, I recommend, okay, first of all, some of you may notice that, hey, Teacher Titan, in the unit 14 or the mole calculation in acid and base, we will use capital letter M to represent mole per dm cube, right? Capital letter M is a short form, right? But in this unit, in the equilibrium section, the examination authority mentioned that students are not allowed to use capital letter M in their answer. Alright, not our answer, but it is okay for draft, right? So I give you a big hint. Now here I use a green color, green pen. Okay. For A square, the unit is M square. For B is M. For C, M. For D is M to the power cube. Right. I only mention the unit here. And now you can see this one can be cancelled out, right? So finally, the answer should be 1 over capital letter M. Well, don't worry, this is draft only. Okay, draft only. So finally, let me write down the answer. 1 over capital letter M is this one. And our answer is mole per mole dm cube. Well, I think this is a small trick for you to get the correct unit in a short time. So everyone, I recommend this to you, okay? Right, so what about the backward reaction? Now backward reaction, I used a different color. Backward reaction this time is C D to the power cube A square and B. Okay, now with the same idea, okay, so you can try by yourself. This is M to the power cube, M square, M. Okay, again this can be crossed out, right? So the final unit is M, which is mole per dm cube. Is fine. So you can see, actually, for the same reaction, if you study forward or if you study backward, they will have different value of Kc and different units. So this is why you should include your chemical equation in your answer. Otherwise, no one will understand which equation you are talking about. Forward or backward, I don't know, right? Right, this is question 2 and question 3. So please do it right now, and I will check the answer for you. And yes, you pause the videos and I will give you the answer. like this. Alright, so for the part B, so you can see that sometimes with the chemical equation, yes, every unit are cancelled out. So yes, there will be no unit. It's possible, okay? Don't trust yourself, okay? It's nothing special. And with question 3, so this is the first time you come across the calculation. Yes, please get your calculator ready. It's okay. Right. So next one. So first, please help me to write down this, okay? Which is part A. And again, please pause the video and until you finish your job. Right. Sorry for the poor handwriting here, right? So you can see I have finished the expression for KC1 up to KC4, right? But if you are careful enough or if you have strong mathematics background, actually you can find there is some relationship between all these 4 equations. Now, before we go further, so let's see. Actually, KC1 to KC3 actually representing the same chemical equation. No matter the reactant product or the coefficients, actually they are the same. But with different ratio in coefficients, they got different equilibrium constant value and unit. So can you find out the relationship between them? Yes, so here is the point for part B. So let us finish now. If you study KC2, actually this is a KC1's square. So that means if one day you can find the value of KC1, now it's easy. Just type in your equation in Google and you can get the value of KC1. And you can calculate the value of KC2 by yourself in simple mathematics. Similarly, what about KC3? Is the square root of KC1, right? Or finally, what about KC4? A bit challenging, right? Yes, this is a reciprocal of KC1. That's it. Well, the importance of this calculation is allow scientists to find out the value of Kc by themselves with the given information. As I mentioned, most equations you have come across, the scientists have done it already. They have found the value of Kc already. But in order to tailor-make your own job, you need to have simple calculation. And now it's your turn. So again, pause the video and start your job. So you can see the value of KC2 is actually the product of KC and KC1. Like this. Simple math, right? Don't worry. And okay, now if no problem, then here comes an important point. Well, this is tricky, be honest. So please pay attention. Well, yes, the value of Kc include the concentration ratio, yes, but actually not every species mentioned in the equation are required to put it in the equilibrium constant. Pure solid and pure liquid are special case. Well, the principle behind is like this, because pure solid and pure liquid, their concentration will not change. The reason behind is simple, because the concentration of pure solid is actually the density. The density will not change, right? So with this one, well, originally the Kc is this one. This is the first draft, right? But since this one is already a constant, and this one is a constant too, so this is no point for us to put two constants here. So we just eliminate one of them to be this is the final result. And this is why the physical state, as I mentioned, should include in your answer, because this is a reminder to remind yourself. Okay, so please highlight this. Well, next, pure solid is simple, but what about pure liquid? So we, sorry. Now, pure liquid, there is a special component is water. So if water is mentioned, so please pay attention. This is a tricky. Now, water actually, they have two characters, okay? They can act as a solvent in aqueous system. The second one is a liquid, or act as a reactant or product. Now, this is very, very complicated. If in case 1 solvent, then the water concentration is not included in your Kc. The reason behind is because this is a solvent already. So one molecule more or one molecule less in water will not affect the result, because H2O as solvent, that means in excess. So change in concentration of H2O is not significant. So water is not included in Kc in case there is aqueous system. Okay? But what about in case 2? If there is no one in aqueous, then H2O should include in Kc. Alright, just give you an example. This is a very good example here. So you can see everyone is in liquid form, no one in aqueous. Okay, no, not AQ. So H2O here is added as a product, so of course it should include it in your answer of Kc. But if anyone exists in AQ, then forget it. Alright? So please pay attention. Well, water is a very special guy. Okay? Well, next one is after some difficult part, let's come across some easy part. Okay? Now, so what is the meaning of value of Kc? So first, if you are strong in mathematics, so you can get the insight already. The value of Kc must be a positive value, right? This is meaningless for a negative concentration, right? So the value of Kc must be a positive value. So what is mean by the value of Kc? And here shows, if the value of Kc is very large, that means we have many products. Easy, right? Or we can say the reaction is almost complete. Almost complete. But what about if we get a small value? Small value is mean between 0 and 1. Okay, this is called small value. Well, we can say the reaction is hardly possessed. We have only a little bit, very little bit amount of product. Oh, sorry to say. So many of reactants still not move or not start their reaction. Okay, so now please, with this checkpoint, help me to arrange the order in order of increasing trend. Which one is almost complete? Which one is hardly possessed? I think this is easy, right? The one should be the highest one and come followed by 4, followed by 3, and finally 1. Like this. Oh, no, not 1. Okay, sorry. 2. Sorry. Yeah. Because the value of Kc for 2 is very small. That's it. Easy, right? Alright. Then here is the important part, so please pay attention. And don't worry, the math is simple. Well, in order to calculate the value of Kc or calculate the value of equilibrium concentration, we have the following step. Okay, trust me, if you follow the step, everything is simple. We have 4 steps called RISE. you should include first a balanced equation in your answer. Then the initial state. Well, initial state means time equals to 0 at the beginning of the experiment. Include the change and include the concentration in equilibrium state, RICE. Well, let's see how this proceeds, right? Now, I have a reaction hydrogen sulfide to decompose H2 and S2. Here shows, now, number of mole, volume, number of mole in equilibrium state, right? Alright, so let's start. Well, this one is the starting concentration, 0.5 mole over 20 dm cube. Yes, concentration, right? So the initial concentration for H2S is 0.025. And sorry to say, we don't have any H2 and S2 at the beginning. So finish, right? We have R and we have I already. We don't know the change, but we know that at equilibrium, only 0.35 mole of H2S remains. Alright, the container hasn't changed, so the final concentration is 0.0175 for H2S. Now, it's easy, right? So, with this one to this one, so it is easy for you to find the change, right? Is minus, oops. The change is here, dropping, sure, right? So, here shows step 1, okay, step 1. Please help me to write down the change for all species in terms of the mole ratio. So, because the mole ratio H2S and H2 is the same, so if H2S is dropped, then H2 should be increased, right? With the same extent. So I think this is easy. And okay, now I'll come across this one. 2 H2S will form 1 S2. So the S2 will increase too, but only in half extent. Right. So I think this is step 1 is very easy for you, right? Okay, here comes step 2. Well, with the starting concentration is 0, easy. I can write down the concentration in equilibrium immediately. Like this. Easy, right? Right. Then I have almost finished my job. Here, I include the value of Kc and I input everything here and get the final result. Alright, the value of Kc is this one. So, simple. Okay? Now, it's your turn. So please finish question 1 and question 2 in your chat point.